Hello everyone, we are going to talk about built-in annotations. Annotations are the powerful feature in the programming that provide a way to add metadata to your code without directly changing its functionality. They are also like sticky notes that you attach to your code, providing additional information about its purpose, behavior, or constraints. Built-in annotations are provided by Java language itself and are a part of core Java API. What are built-in annotations? Built-in annotations are the special markers that you can add to your code, provide information to the compiler or runtime environment. These annotations are predefined and available for use in Java code. They offer a structured and standardized way to communicate information about your code. The first one, metadata. Annotations essentially act as a metadata tags, adding extra information to your code without directly modifying the code itself. No impact on functionality. Annotations themselves do not change the actual functionality of the code. They simply provide the additional context or instructions. Uh, Read by tools. These annotations are read and interpreted by tools, compilers, or frameworks to understand the code better and possibly modify its behavior or usage. Benefits of using built-in annotations. Built-in annotations offer enormous advantages for developers, simplifying code, improving readability, and enhancing overall development practices by utilizing annotations. You can streamline your code and make it more efficient, robust, and maintainable. Code readability. Annotations make your code more readable, self-documenting, providing clear insights into the purpose and functionality of the different elements. This improves the code comprehensions and maintainability, especially for large and complex projects. Reducing boilerplate code. Annotation help in reducing the need for repetitive code, allowing you to express the intent more concisely. For example, you can use annotations to specify validation rules or dependency injection requirements, reducing the need for verbose configuration code. Improving improved code maintainability. By centralizing configuration and metadata through annotations, you simplify code modification and maintenance. Changes are easier to track and implement, reducing the overall risk of errors and enhancing overall code stability. Common built-in annotations. Java provides a set of commonly used built-in annotations that addresses a wide range of development needs. These annotations are designed to simplify and enhance the code development practices. Annotations are used for purposes. Override indicates the method overrides a method for superclass. Mm, Deprecated marks a method, class, or a field as deprecated suggested that it is no longer to be used. Suppress warning suppresses the compiler warnings related to specific issue in your code. Safe varix indicates the method is safe to use with the variable and length arguments, even though it might not be generally safe. Functional interface indicates a interface is intended to be used as a functional interface having single abstract method. Syntax and usage of built-in annotations. Using built-in annotations is a straightforward and involves adding them as a markers before the element they apply to. Annotations can be used to enhance the methods, classes, fields, and other elements. Annotation syntax. Annotations are written using the at symbol followed by annotation name, often with the operational parameters in the parentheses. Placement. Annotations are typically placed before the element they modify. For example, at override is placed before a method declaration. Example, Java at override public string to string return my object. Close bracket. Annotations and reflections. Reflections allow you to examine the structure and behavior of your code at the runtime. Built-in annotations play a vital role in reflecting and providing a way to attack metadata to your code that can be accessed and used by reflection APIs. This enhances the flexibility in the dynamic capabilities and your applications. Inspecting annotations. The java.lang.reflect package provides classes and methods for inspecting annotations at runtime. Runtime behavior. You can use reflections to dynamically access the interpret annotations information, allowing you to modify behavior or adapt your applications based on your annotation values. Configuration and customization. Annotation can be used to provide the configuration data that can be loaded and interpreted at the runtime using reflection. Customization and configuration. In this, annotations can be used to provide configuration data that can be loaded and interpreted at the runtime using reflection. Annotation and dependency injection. Dependency injection is a powerful design pattern that promotes loose coupling and code reusability. Built-in annotations plays a crucial role in simplifying the standardized dependencies injection in Java. Popular dependency injection framework like Spring extensively utilize the built-in annotations to configure and manage the data. Component scanning. Uh, Dependency and injection framework use annotations to scan your code base and identify the classes should be managed as beans. For example, that component is used as a mark of a class as a bean. Dependency injection annotations like at auto-wired are used to inject dependencies into your classes. These annotations tell the framework to automatically resolve and provide the required dependencies at runtime. Configuration annotations can be used to configure beans such as specifying their scope, name, and other settings. This allows for declaration to approach configuration, making your code more readable and maintainable. Best practices for annotations. Using annotations effectively and adhering the best practices is essentially for maintaining code quality and readability. By following these guidelines, you can ensure that the annotations contribute to the well-structured and maintainable code base. Purposeful usage. Use annotations strategically to provide a meaningful metadata, avoiding overusing annotations as they can clutter your data and make it difficult to read. Uh, Clear naming. Uh, Choose annotations names that are descriptive and clearly indicate their purpose. Use conventions like add prefixes for annotation names to enhance the readability. Documentation. Provide clear documentation for your custom annotations explaining their purpose, usage, and any parameters. This helps the others to understand your code and use the annotations correctly. Consistency. Maintain consistent naming and usage convenient for your annotations across your code base. This ensures that the code is uniformly and make your code easier to understand and maintain. Thank you. That is the end of today.